Hello. In today's lab, we will investigate the conditions under which a rigid object such as a meter rule will remain in equilibrium. And equilibrium means a state of balance. Now, from the theory class, can you tell me what are the conditions under which a rigid object will remain in equilibrium? Well, if an object cannot move in the x direction, it means the summation of all the x forces acting on it is zero. Now this is the condition that the object will not move in the x direction. Similarly, summation Fy equal to 0 will make sure that the object will not move in the y direction. Now we will not be considering motion in the z direction. That means summation Fx equal to 0 and summation Fy equal to 0 will establish the translational equilibrium. Equilibrium in relation to linear motion. There will be no linear motion in the x direction or y direction under this condition. But an object can rotate. Now, what is the condition under which an object will remain in rotational equilibrium? The sum of all the torques of all the forces taken any axis must be equal to 0. So these are the three conditions that we very often apply in solving problems on conditions of equilibrium. Now what does this mean? Summation of tau equal to 0, sum of all the torques, which obviously means torque is a vector quantity. There are positive and negative torques. And for our purpose, we are going to simplify it by saying that any force that produces a clockwise torque will be negative, and any force that produces a counterclockwise torque will be positive. Now, let's look at the rotation of the meter rule about an axis like this, a horizontal axis. If I apply a force on the ruler here, look at now what is the direction of rotation? It is clockwise. Whereas if I apply a force on the other side, the rotation is counterclockwise. So this force produces a positive torque, whereas the force on the right will produce a clockwise torque. So a counterclockwise torque is positive and a clockwise torque is negative. And when there is rotational equilibrium, as we have now, that means the sum of all the torques acting on the rigid object is 0. We will apply these three conditions to form equations and then solve for the unknowns. That's the method we will use in this lab. In order to work out the conversion factor, I want you to measure the length of this ruler. I'm going to keep it on my blue background. Measure the distance from one end to the other. Alright, I'm going to keep it still. Measure that length on your computer screen. Okay? What is the actual length of the ruler? It is 30 centimeter. So measure the length of the ruler on your computer screen and work out the conversion factor. Alright, I'm going to take the ruler away now. I hope you have finished measuring the length. Okay, now the conversion factor is, calculate your conversion factor as C equal to 30 centimeter divided by the distance you measured on the computer screen. And this conversion factor will be used right through for all the 3 experiments. I will not change the settings. In this lab, I have asked you to work with 3 procedures. In procedure 1, you are asked to balance the ruler like this and determine its center of gravity. I have balanced the ruler at its center of gravity, and I want you to measure that value. What is the center of gravity? I will zoom the camera onto here, and I want you to measure that value. But before I zoom it, let me show you this. This is the 60 centimeter mark, and this is the 40 centimeter mark. I'm going to zoom in onto this region and watch it. Watch the reading as I zoom in. You need to read the reading corresponding to this point. That is where the balance is. And you can see that's 41, 42, 43, 48, 49. And I'm going to zoom in and measure that. Okay? Measure and record the center of gravity. Alright, take a note of that. Your center of gravity is at the 50 centimeter mark. And now, we now need to balance the ruler at the point C. Now, I need to move this away from here to a point C so that the distance GC. So I move the balance point from G to C so that the distance GC, which I'm going to call X, and the first value of X is 4 centimeter. So if 50 is the center of gravity, I move it to 56. There you are. So I move it to 56. Now I'm going to balance it at that point C. But in order to balance it, I need a force on this side. Now what do? I need to use a 100-gram mass. Here is a 100-gram mass, and I'm going to use a string to hang the 100-gram mass. Alright, let me retrieve my 100-gram mass. There it is. Now I have the 100-gram mass hanging from the ruler. I need to change its position. Alright? Change its position so that the ruler is balanced. Well, again, it takes patience. Is that right? Okay. Let's see where it's going to be balanced. Alright, it's nearly balanced. Now what are we supposed to do? Well, I need a little tweaking there. A little more. I had it exactly balanced. But now, well, okay, a little more. I think it is balanced now. Now, you are required to measure a distance. Now, what is the distance you're supposed to be measuring? You're supposed to measure the distance from C to D. Now, let me point out where that string is. This is where the string is. That is where the 100-gram mass is suspended from. And you need to measure the distance from the center where I'm pointing to the position of the string. Alright? Now that distance is lowercase d. Measure that distance. Well, I have now changed the string, and maybe it is easy for you to measure that distance. This is the distance you need to measure. That's your D. Alright, measure that distance and record it as D. So, when your X value is 4 centimeter, what is your D? Your measured value must be multiplied by your conversion factor. Now we need to repeat the experiment, changing X to 6, and then 8, then 10, and 12, and each time measure the distance D. So let me change the distance X. You can see I need to move the ruler 2 centimeter. Alright, I move the ruler 2 centimeter, and then I need to move the mass away. Now what is the new D value? Well, let's see how that balances. Getting closer. Alright, it's very nearly balanced. And now measure that distance. Which distance is it? Alright, measure this distance. That's your new D. The distance from C to D is your lowercase d. Okay, measure that distance. Alright. Let's now change X to 8 centimeter. I need only move it 2 centimeters. So let's do that. There we are. I changed so that X is now 8 centimeter, and of course I need to move the mass. Alright, and let's see where the balance is now. Okay, measure that distance, which is your D now. That is your D now. Measure that distance. Okay. We measured. Okay. Now we repeat this for X equal to 10. So I move the ruler another 2 centimeter. There it is. And balance the ruler again by moving the mass until we get the balance. Are we balanced? Almost there. Okay. Well, a little bit. Getting a little tricky, isn't it? I think we are ready to measure that distance now. Okay. Alright, measure this distance, the new distance D. I will keep it here for you and measure that distance. Okay, that's your new D. Got to measure it very accurately because it's not changing a lot. Okay, measure that distance. And now we change X to 12 centimeter. Alright, change X to 12 centimeter. There it is. X is now 12 centimeter, and I'm going to move the mass to produce the balance. We got a balance, very close. Alright, measure that distance. Measure the new D. Let me point out that for you. Measure this distance, that is your new D. Measure that. Okay, measure that and multiply it by the conversion factor. Okay, now let's increase x by another 2 centimeter. Okay, that will be now x equal to 14, is that right? Well, you keep track of that, and let's measure the new D. Well, that looks almost balanced, maybe a little. Okay, measure that new D. Alright, you must be quick to measure it. If you use your dividers or compass, it's very easy to measure that distance. Alright, measure that new D for x equal to 14. Okay, now let's increase x to 16. Now I think it was x was, alright. Now here I have the new x value. I'm increasing x every time by 2 centimeter, and you keep track of the number. And I have the balance there. Okay, measure the distance D between these 2 points. That's the new distance D. Measure that distance. Okay, measured. Alright, now let's increase the distance by another 2 centimeter, so that I think x is now 18 centimeter, is that right? Alright, and there we go. That's almost a balance. Okay, measure the new distance D. There you got the new distance D. Measure that distance. And remember, all measured D values must be multiplied by the conversion factor. Okay, there we are. Let's now change x by another 2 centimeter, so that x is now 20. Is that right? I think that should be our last. And let's measure the new D. And I think we have a balance there. Well, almost a balance. Okay, measure that new distance D. Measure that distance D. Okay. I want you to do it for 10 x values. If you haven't got 10, I'm going to do one more. So I'm going to increase it by another 2 centimeter. X is now increased by another 2 centimeter. Let's find the new D. And I think we have a new D there. So measure that D. There you are. Measure that D. multiplied by the conversion factor, and now you have a number of x values and the corresponding d values. Tabulate that nicely, okay? Let me now take you through the interpretation of the data. Look at that page, page 2 I think. If W is the weight of the meter rule, what are the 3 forces acting on the ruler when it is in equilibrium? When the ruler is in equilibrium like this, what are the 3 forces acting on it? Now remember, the weight of an object will be always acting through its center of gravity. So this is the center of gravity of the ruler. Therefore, this is the weight of the ruler acting at the center of gravity. And of course, at the balance point, there is a reaction force acting upward. That is the reaction force. And then, at D, there is a force applied by the weight of this 100 gram. What is the weight of 100 gram? I'm going to remove this and draw the force vector. The force vector there is the weight of the 100 gram. 100 gram is 0.1 kilogram times 9.8. That is 0.98 Newton. So, the 3 forces are, let me use the black ink. Weight of the ruler, the reaction force, and the weight of the 100 gram, that is 0.98 Newton. Now, draw a diagram showing all the forces acting on the ruler when GC equal to 4 centimeter. For the first part, remember the first trial we did, this GC is 4 centimeter. And we measured the value of D. You know that value of D. I'm going to call it D, but you must use the measured value of D there. And then, what are you supposed to do? That is 4 centimeter, that is your D. Mark all the distances. So we have now all the forces. This is the weight of the ruler, that is the reaction force, that is the weight of the 100 gram, and the distance from G to C is 4 centimeter. The distance from C to D is D, the measured value. You have to use the measured value there. And number 3, write an equation using summation Fy equal to 0. What does that mean, summation Fy equal to 0? If an upward force is positive, the downward forces are negative. So it will look like this. Summation Fy equal to 0 gives me R minus W minus 0.98 equal to 0. And that is the equation using summation Fy equal to 0. The upward force is positive, downward forces are negative. Now, step number 4. Take the torques of all the forces acting on the ruler about the point A. Now, where is the point A? Where GC equal to 4 centimeter. Now, the point A is the end of this ruler. Now, take the torques of all these forces about the point A. Now, remember, what is the definition of torque? I'm going to write it over here. Remember, torque is the perpendicular distance of a force multiplied by the force. So the torque of this force W will be W multiplied by that distance. So I'm going to write that in here. Torque of W. Torque of W is W multiplied by this distance. This is the center of gravity. That means this distance is, what is that distance? 0.5 meter. So we will write the torque as 0.5 meter multiplied by W. So that will be 0.5 times W. Meter Newton is the unit of torque. Now tell me, is this a clockwise torque or a counterclockwise torque? Now this is our axis. The axis is the axis passing through A. And look at what W can do. W can rotate in a clockwise direction. That means this is a negative torque, and I must make that sign clear there. So that torque equal to negative 0.5 W meter Newton. It is a clockwise torque. Now what is the torque of R about the point A? The torque of R equal to the distance of R. If you look at the distance of R is acting through C. The distance AC is 50 centimeter plus 4 centimeter. That is 0.54 meter multiplied by the force. What is the force acting at C? Is the reaction force. Tell me, is that a positive torque or a negative torque? This is the axis of rotation at A, and R is upward. That means it will rotate the ruler in the counterclockwise direction. Therefore, this is a positive torque. Alright, let's now find the torque of this 0.98 Newton. The torque of 0.98 Newton is, what is that? The torque of 0.98 Newton will be, the distance of that force is 50 centimeter plus 4 centimeter, that is 54, plus D. Only you know that value, I don't know. So add all those, 50 plus 4 plus D, and write that in meter. Well, I'm going to simply call it, want to call it D, big D. But for you, there must be a value for that. Times 0.98. Now, is that a positive torque or a negative torque? The rotation produced by this force about an axis through A will be clockwise. Therefore, this is a negative torque. And now, number 5 says, in number 1, you need to write an equation. Summation tau equal to 0. Add all these torques. You have negative 0.5 W plus 0.54 R minus 0.98 D minus 0.98 D. Now remember, you know a value for D, so this is a number, and this equal to 0. Now we have now two equations. The first equation we obtained by setting summation Fy equal to 0, and that was R minus W minus 0.98 equal to 0. Now if you look at this, there are two equations, there are two unknowns. W is an unknown, R is an unknown. Remember, we know the value of D. Alright, now solve these two equations for W and R, and that is number 5. Now in order to do steps 4, 5, 6 and 7, we just used one of the experimental values. Now let's take the general case. in number 8, it says, take the torque of all the forces acting on the roller about the point C when this distance is called x, that is a variable. So this time it is no longer 4 centimeter. That 4 centimeter is for one of the experiments. Now this time x is a variable and d is a variable. Now tell me, what is the torque of this force W about this point C? It will be, the distance is x and the force is W. That will be the torque of, so the torque of W about point C will be x times W meter Newton. X is the distance, W is the weight. Tell me, is that a positive torque or a negative torque? This is the axis of rotation, and W will rotate the ruler in the counterclockwise direction. So this is a positive torque. Now tell me, what is the torque of R about C? If you notice, R passes through C. The distance is 0, therefore the torque is 0. I hope you remember, if a force passes through a point, the torque of that force about that point is 0. So the torque of the force R about the point C is 0. How about the torque of mg? Look at this. We suspend a mass m from there. The force therefore is mg, where m is 100 gram. That is a fixed number. So we have, I'm going to change that. Alright, mg is the weight of 100 gram, which is 0.98 Newton. We know that. So what is the torque of 0.98 Newton about C? The torque of 0.98 Newton about C is this distance, which we call d, d multiplied by 0.98. So that will be 0.98 times d meter Newton. Is that a positive torque or a negative torque? If this is the axis of rotation, this torque rotates in a clockwise direction. That means that is a negative torque. Alright, now apply the equation summation tau equal to 0 and form an equation. What is that equation? It will be x times W minus 0.98d equal to 0. Is that right? So that will be x times W minus 0.98d equal to 0. That is the equation. Now, can you write this equation in the form y equal to mx, knowing that x is a variable, d is another variable? Well, which is the independent variable? We change x and then measure the corresponding d. So x is the independent variable, d is the dependent variable. That means we need to solve for d. Can you solve for d from there? Well, if you solve this equation, we get xw equal to 0.98d, or d equal to w over 0.98x. That means if you draw a graph of d on the vertical axis and x on the horizontal axis, w over 0.98 will be its slope, and from then you can obtain a value for the weight of the ruler. Remember, not the mass, but the weight. That would be Newton. And if you divide that by 9.8, it will give you the mass of the ruler. And we can actually measure the mass of this ruler on a balance right? You want to do that, and you can then obtain the percent error between the experimental value of the mass. Remember, the slope, from the slope you calculate the weight, and if you divide that weight by g, you get the mass of the ruler. And let's now measure the mass of this ruler. Alright, measure the mass of the ruler, zero in the balance, and now measure the mass of the ruler. This is the actual mass, and you have an experimental mass. Find the percent error of your experiment. Look at procedure 2. Balance the meter rule at its center of gravity. I have balanced the meter rule at its center of gravity with a mass m equal to 20 gram at a distance 10 centimeter from G, so that this distance is 10 centimeter. Okay, and now suspend an unknown weight marked W. I have suspended this unknown weight, that is W, from the other side and balance the rule again by adjusting the length. I have actually balanced the ruler. Now look at it. The ruler is balanced at its central gravity and a mass m. Now this is going to be a variable. So I'm going to call this m. At the moment the first value of m is 20 gram. I have suspended 20 gram so that this distance is 10 centimeter, and that's going to remain a constant. And we have an unknown weight W. You vary the position so that the meter rule is balanced. Now measure that distance. Now let me tell you something. In the first part of the experiment, I changed the setting after the first part. So I want you to obtain the conversion factor one more time. Alright? Obtain the conversion factor. There is the 30 centimeter ruler. Measure its length from one end to the other and obtain your conversion factor one more time. Although I promised you that the first conversion factor is good for all the three, I simply changed because when we wanted to measure the mass. So measure this distance. 30 centimeter divided by this distance is your new conversion factor. Remember to use that. Okay? And now measure this distance. The distance from G to the position of the unknown mass. Alright? Measure that distance. Well, I disturbed the system, so I need to reset that and get the balance again. I was not supposed to touch it. I have now a balance and measure the distance x between the points that I indicate. That is your x. Alright. Now this is the value of x when the mass m equal to 20 grams. Now what is it that we need to do? Now repeat the experiment for m equal to 40, 50, 60, and each time measure x. So I'm now going to put 20 more gram and let's measure the new x. Alright. There, almost you got a balance. So you got the new x and let's measure that distance. Alright, measure that distance. That is your new x. For m equal to 40 gram. Okay. Now let's go and make the mass equal to 50 gram. I'm going to put a 10 gram, an additional 10 gram, making the mass 50 gram. And now let me move so that X now changes. Okay, there we have the balance. Now measure the new X. For M equal to 50 gram, measure the new X. Okay, measure. Alright, let's now make the mass M equal to 60 gram. What I'm going to do is I'm going to remove all these 20s, put in a 50 and a 10, and that makes it 60. So this is a 10. So 50 plus 10, I have a 60 now. And let's now obtain the new X. Okay. I think I have a balance there now. This is now the new X for M equal to 60 gram. Measure this X. Okay. Alright. Now let me make it 70 gram. I remove 110 and I put the 20. That is 70 gram. M equal to 70 gram. Let's measure X. Balance? Almost. Okay, let's measure the new D now. Measure the new D for M equal to 70 gram. That is the new D. Measure that distance. Okay. Let's now change the mass to 80 gram. There I have 80. And let's measure the new X. Okay, we have the new X there. Measure this X value for M equal to 80 gram. Okay, we've got the new X there. And now M equal to 90 gram. What I'm going to do is take 110 out and put in a 20. I have M equal to 90 gram and we will find the new X. Alright, I think I have a balance there. So measure the new X there. There we are. Alright, after measuring, tabulate the values of M and X. And then use this diagram to obtain an equation connecting M and X. If you take the torque about G, what you get is W times X will be equal to the weight of M. The force here will be M times G. So that will be Wx equal to 0.1 times mg. And I'm going to leave that there for you. Now our variables are, m is the independent variable, is that right? And x is the dependent variable, and we need to find the value of w, the weight of this object. So you need to write this equation in the form y equal to mx so that the slope will contain W. Alright, I'm going to leave that, answer all the questions in that procedure 2. And I'm going to now take you to procedure 3. Now what does that involve? For procedure 3, you are required to find the center of gravity of the ruler, which you know is 50 centimeter mark. And now balance the ruler at point A, where A is the 40 centimeter mark. There, A is the 40 centimeter mark. Balance it there by suspending a 100-gram mass from point B so that AB equal to X. This is the 100-gram mass from point B so that AB equal to X. Measure and record that X. Alright, measure this X. Okay, and multiply with the conversion factor. And now in this experiment we will be suspending masses from the center of gravity, and for this trial the mass suspended at the center of gravity is 0, and write down the value of X corresponding to m equal to 0. So you will have a value of X there. And now suspend a mass of 20 grams from the center of gravity. So I'm now going to suspend a mass of 20 grams from the center of gravity. That means I need to move the position of the 100-gram mass. I have now a 20 gram at the center of gravity, and I move the 100-gram mass so that I get a new value of X. Alright, let's measure that new value of X. Measure that X value and multiply with the conversion factor. Okay? Alright, and now repeat the experiment. You got m equal to 20, write down that X value after multiplying by the conversion factor. Now repeat for m equal to 40, 60, 80, 100 and 120. So I'm going to put in another 20 so that the mass at the center of gravity is now 40, and I'll change the X to get balance again. I think I have a balance there. Alright, measure that X value. That corresponds to the X value. This is the X value for m equal to 40 gram. There you are. Okay, measure that X value. Okay, now increase the mass to 60 gram. I need one more 20 gram. So this is now the mass equal to 60 gram, and I change the value of X. Let's measure the new X value. Ready to measure it? Alright, measure the new X value for m equal to 60 gram. There you are. Okay. And now let me change the mass to 80 gram. I'm going to put one more 20. That's 80 gram there. And let's find the X value. Alright, I think we have a balance there. Measure that X value. Well, it's very close to balance. Okay, measure this X value now. And that corresponds to m equal to 80 gram. Okay, well that's the actual distance. Measure that distance. Okay, there you go. Now I change the mass to 100 gram. Alright, I'm going to take off all these 20s and replace it with 100. Okay, have the new x value for m equal to 100 gram. Okay, measure that and multiply it with the conversion factor. Okay, and now change the mass to 120 gram. That's 100 plus 20. I have 120 gram, and we change the x value. We have a new x value. Measure that new x value. There you are. Okay. Right. Now complete this table for m against x. And then to answer the questions, I'm not going to answer them for you, but I'll give you some clues here. What are the forces in here? If you at B, it is the weight of the 100 gram mass. So I'm going to draw that force. The weight of the 100 gram mass is 0.98. Is that right? This is the 0.98 Newton acting at B. And at G, what are the forces there? I want you to watch that carefully. Remember, the weight of the ruler will be acting through G. So, if big M is the mass of the ruler and the small m is the mass you suspend, that means the force that is pulling the ruler at G will be the mass of the ruler plus the mass you hang there times G. That means when you take the torque, this distance is 0.1, is that right? Okay, and now write down the torque, the force multiplied by this distance, 0.98 multiplied by x will be equal to m plus small m times G multiplied by 0.1, the distance. There you are. Now, I'm going to rewrite this like this. It will be 0.98x equal to, if G is 9.8, 9.8 times 0.1 is 0.98. That will be 0.98 times m plus m. Isn't that a good equation? Alright, I'm going to now leave it for you. This equation, you can see this is 0.98. That 0.98 and 0.98 will cancel. There is no x there. The right side is 0.98 times m plus m. So that will give you x equal to small m plus big M. You see that? What a wonderful equation. This is of the form y equal to mx plus b. I want you to draw the graph of x against m. M is the variable there. And obtain the slope. And what will the slope be? And what does this represent? I want you to interpret it. Alright? And answer all the questions. And I think that will be the end of this lab. Now, once you answer all these questions, it gives you a good understanding about equilibrium of rigid bodies. And I want you to take time and think about it and answer all the questions well. Okay? And I think this is your last lab. Alright, now you have one more exam left, and make sure that all the labs are submitted. I hope you submitted all the labs on time. Okay, I will see you for the last exam later on.